So what I'm going to talk today, it's a little bit different from what John has taught, and it's just a bit on a little flash introduction to how to work with geospatial data, and in the end, just to have a play on what are the kind of things that we can do with it. So I just put it at the title with playing with geospatial, but you can take it as a really flash introduction to a few of the Python tools and a few of the functionalities that we can do while working with it. So first of all, it's really, whenever I say geospatial data, it seems really fancy, but what is actually geospatial data? And in the end, is whatever data that we can see that we work on a daily day, you can imagine even as a table. And the only difference that we can see, that we categorize as being geospatial data, it is whatever we are looking at, we'll always have some geographical position attached to it. So for example, if you look at your Google Maps applications, if you look at, I want to take a route from A to B, or I want to see how much time I will take, all these locations, all these streets, these positions, and even the time to calculate from go to A to B, it has all these latitudes and longitudes presented on it. A second example, this is a satellite imaging, and it's really taking aerial images from a city. It can be from any place on Earth. And then we can use some algorithms, some other image processing or other things, and try to, for example, segment some buildings or bridges inside this image. And again, this kind of works that we do, or not we do, but usually related to geospatial, is always normal data points, buildings, tables, or whatever, but having some form of spatial location, latitudes, longitudes, and so on. And I'm going to talk a little on how to build maps, as the title of my presentation is, but then I just want to give the main source of data that I'm going to collect from. And this is something that I always want to try to evangelize a little bit and to get people to know a little bit of OpenStreetMaps. And what is OpenStreetMaps? And if we go to, let me get out of here. This is a little bit of spoiler, but I wanted to show just a bit of OpenStreetMaps. And OpenStreetMaps is really what you see on Google Maps. And it has all the map features, cities, buildings, locations, the streets. But the difference from Google and OpenStreetMaps is that this is open source. So this is actually curated and treated and every day changed by people who are actually giving them free time or giving them volunteering time in order to give this really good quality map data for us. And on contrary to Google, we can actually take this data and do a lot of things, including one of the things that I'm going to show on today's presentation. So what are the things that people actually use for using OpenStreetMaps data? So you can calculate your routes from A to B. If you have a place on one place of the city and want to go to another, you can use OpenStreetMaps to have your own custom router without having to use Google. There's some technicalities you can use as a geocoder for whoever works a little bit more on these fields. And even, this is a really interesting part, actually people from underdeveloped countries can use OpenStreetMaps as more as a humanitarian act platform. And what do I mean by this? So suppose you have some really environment disasters such as tsunamis or hurricanes in certain places of the country. If the country is really underdeveloped, or if the place that is affected is really underdeveloped, people can go after the disaster, look at the satellite images, map how the new streets are, maps or what areas are accessible, what areas are not accessible, and this can be used for governments to plan on how they're going to react to this kind of situations. So this is actually something pretty nice if you want to get engaged with. Okay, but enough about OpenStreetMaps. Let's talk a bit of a little what we're going to see or do today. So first of all, why I started this topic to create this kind of map. Actually, I just started with, I wanted to give some kind of customized presents, customized gifts for a friend. I think she's here on the presentation. I hope she's not offended by this. But the main feature that I wanted to kind of connect to, and that she really enjoyed to have some little lots of alcohol. So whenever we went out, we hanged out, having some beers, having some other drinks is actually a high point of the day. As I said, she really enjoyed having some drinks. And our daily day work was actually working on this kind of geospatial data. So whatever I talked about, OpenStreetMaps, location, places, it was all involved in our daily day. So a main question that I wanted to do, if I want to give like kind of a custom gift, is how could I join these two topics somehow? And the answer for this, we could create a map for her. So this person is actually from Bosnia, from Sarajevo, and we could try to connect the map and the locations and actually connect to her all the places that she could grab some alcohol somehow. So it's basically a alcohol recommender system for a location recommender, I would say. So the more red the places are, more concentrated and easily we could have access to places that sells alcohol for us. This could be really useful for other people. I know a lot of them that could have a good usage for that. But it's nice because as we're going to see on Python, it's basically some standard procedures, some standard functions that we use to extract, process, and plot this data. So basically, we can exchange with a few parameters and produce something for our own specific city. And this is what I wanted to show today. Right after the talk, I'm going to put the repo and the notebook that I'm about to show on the comments on Twitch, and you can have access to this. But on this link, you're going to be sent to the notebook. And what I've done today, I'm going to the end. I just used the same functions, and we are going to create the same plot, but for Berlin. As we are based in Berlin today, I thought it was a cool experience to try to do. All right. Again, this is a really flash introduction to geospatial data. I want to mainly show you some visuals about the operations that we can do, and not actually go into details of what are the frameworks, what are the optimizations that I'm doing inside the codes, because each one of the topics I could be talking for one day or even more, like infinite if people let me. So it's actually good that we have 30 minutes. And if anyone has any further interest and want to access the notebook, understand what has been done, feel free to after that contact me. I will pass the GitHub credentials or GitHub link, I say, and people can ask me. But here, my point is really not to get into details of how everything works, but just a little bit. So as I said, all the data we are going to get is from OpenStreetMaps. In order to have that plot from Berlin that you saw, we need two kinds of informations. One is really how the street network layout is. We want to have an idea of where the streets are, what are their lengths, and do some operations with them. And the second one is the points of interest. So all the places that sell alcohol. So we can do some operations with these two data sources, and then at the end produce that image at the end. So where do I get this street network? Well, there's a lot of frameworks, a lot of ways to make easy to process, to extract and process this data from OpenStreetMaps. And the one that I like the most is this Python package called OSMNX. So this is just an acronym, and it means extract networks from OpenStreetMaps. OpenStreetMaps network, and NX is a network package from Python. And it's quite easy, actually. So if you use the package, you can just say, take me the street network, or take me the graph, because at the end is a graph, from some specific city. This parameter is basically Berlin, Germany, in this situation, this notebook. One function, we can already plot it. And on this object, we're going to have all the networks present in Berlin, whatever how is defined in Berlin here in this case. The second data set, the second data source, is going to be the poise. Again, we're going to use OpenStreetMaps, but as OSMNX is really focused on extracting street networks, we need something else to extract the points of interest. And what I do, again, there's always some Python package to do it. We're going to use a package called PyOsmium. Don't get too attached to these names. You're going to have access to the notebooks. It's really more about what these tools can do, and you can understand what they can do instead of knowing their names and etc. So with PyOsmium, we are going to do all the processing, and at the end, you're going to have a table. And this table is really about, if you look at this table, it's just the name of the place, the kind of the place it is, it's called amenity, and its location, considered composed of latitudes and longitudes. So one of the insides of the function that I executed to extract the points of interest is that a point of interest can be anything. The interest is really generic, so it can be a park, it can be a tree, it can be a dentist room. But for us, in this case, we're really interested on whatever place can sell us alcohol. And the way we can do that is really by filtering the kind of amenity these points are. So we have a filter here of all the amenities of all the kind of places that I want to keep from the points that I got from OpenStreetMaps. This came from my mind. So I thought for myself, if I'm a person, I really want to grab some alcohol, and if my criteria is not so high, to be honest, we can look at all these places coming from restaurants, nightclubs, brothels, pubs, bars, maybe hookah lounges. I don't know. I've never been, but this might be a place. I just put a name as a conservative guess. And this list applied to the functions that I showed above from PyOsmium resulted on this table for us. So for now, we have everything we want. We have the street network, and we have the points of interest. So how do we take this and then create that map that you saw at the end? That goes a little bit on the logic itself. So you're going to see everything that we're going to see for the next steps is really about these 4 points. So what we have done until now with the points of interest, it's basically this map here. And by the way, this map is also generated inside my Python codes. If you run in our house, you will produce the same kind of map. But this is basically all the points of interest that I extracted from OpenStreetMaps and plotted inside Berlin. So if you want to do a heat map of all the places that can sell alcohol potentially, we already have some perspectives of what are the most popular places are going to be, because you can see already some densities of points, for example, on the central north, a little bit on the west side, and a little bit on the east side as well. So this is everything that I extracted from OpenStreetMaps with that one function. So what we're going to do in order to create this kind of heat map, imagine that I take each one of these points. Let me zoom in. I will zoom into a point that's more or less isolated so we can show my points. So let's take this one. It's a subway. Okay. So we're going to take this one point, or imagine that I'm going to do that for every point, and I'm going to expand it. So imagine creating a radius of some certain size, some certain number of, with some certain radius around it. And this is how it's going to look like. Right? So for each one of these points, for this subway here, I basically created a radius of, in this case, is really custom. I decided for 500 meters. And whatever streets is covered inside this radius of 500 meters, I would say you can easily access the subway restaurants. It makes sense, right? And if it's close by and see 500 meters, you can still go out and order, or you can get something. I mean, for regular days, for Corona, maybe a little bit more careful. But in general, we're going to do this radius for all the points we have. And for each one of these points, I'm going to count how many streets fall inside the circle. So at the end, the streets or the circles that has a higher count, I will color as a different color. So for example, from white to really low counts to reds having really high counts. So this is a little bit of the visual of what I'm doing here. And this is how you can see when I do for all the points inside Berlin.
Lucky.
So coming back to the notebook, and it's nice that you can see the densities again. We already know what are the main popular places that if you want to grab some alcohol for Friday night or Saturday, you know a little bit of the places that you want to go. Cool. Going back to the notebook. So that radius that I created on what you've seen is basically performed, as I said, on the codes. It's a geometric operation. So we get this lat longs that I showed before, and I call this function called buffer. And this buffer, I just want to say, buffer this point, so increase the size of this point by some certain of meters. This is a parameter that I also define in the beginning of the notebook. After this, the same table that you see before, place amenity original points made by Latin long. But I also have the circle defining that circles around the points of the original points. Okay, so as I said, the code that generates the map that I showed is on this cell. You just have to uncomment and execute, and you're gonna have saved as HTML file that you can play with. So what we're gonna do now, so we have that map, we have the points, the buffered points, and the street network. What I'm gonna do is really roads by roads. So remember that this G is the graph, is the street graph that we extracted from before. So it's literally, we're gonna do a for loop over it. And for each one of the streets, I'm gonna check how many circles the street is inside. I'm gonna check with how many circles this street intersects. That's actually a better wording. And as you can imagine, we have probably some hundreds of thousands of streets on Berlin. And we also have some few good thousands of places. So in order to compare all these streets with all these places can take some time. So that's why if you get this notebook and execute, you're gonna spend some time on this cell here. So it actually takes a while. Of course, it's not super optimized, and I'm not worried about like time to execute or anything else, but it takes a while. So if you want to do that, just be patient, take some tea, rest a little bit, and then come back. And after we do this, so after this operation, the results that we have is all the points, all the buffered points, and the count for each street of how many restaurants this street have nearby of 500 meters, let's say. After doing this operation, this intersection line in this geospatial language, we have this. So we see our original points here. This is the same kind of bubbles that you saw from the previous map. And just to be a little bit easier to visualize, I will remove them. But what I've done is also, I took the 100 street segments that had a bigger count of alcohol selling places nearby. So this is, if anyone, there are some people from Berlin, so you can imagine a little bit of why these places could actually have a little bit more higher count of alcohol selling places. So this is more or less the city center. This is more Friedrichshain, also like a more famous place close to Warschaustrasse. It's quite a good place for people to get access to. And here on the south, I'm not sure. Maybe, yeah, it's good to have someone just tell me afterwards. But these are the main places. So these are the 100 street segments that have most alcohol content nearby. And what are we gonna do from this? Oh, sorry, not 1,000. Or I have the 500 more popular places, and we can take a look at what is the 500 more popular, or what is the 300 more popular. You can see that the counts on the streets on the map starts to decrease. And if we go even more, let's put the 100 most popular, or the places with more access to alcohol. We have Friedrichshain. This is a really surprising thing when I saw for the first time. And I talked to one friend, and it actually happens that on this place here near Frankfurt Tor, we have this kind of more gourmet or street markets that used to sell a bunch of things. And this might be the reason that we have, at least that the count is so high, and that, yeah, that the count is so high. And just for curiosity, this is where I live. So yeah, this is actually a good place maybe if you want to have cheers. So maybe on a Friday, Saturday night outside Corona, this is actually a good place if you want to be always sure that you have your supply. Okay, coming back. So now imagine that you have the points, you have the streets, and which is the most important part? Now we have the streets, and for each of the streets, I have the count of how many restaurants are within a certain distance, in this case, 500 meters. Then after the end is really just about doing the final processing. What we are gonna do is really take a look of all the streets. I'm doing a pure for loop. I'm gonna look at the counts, which I have counted in the previous cell. And depending on the count of restaurants or the count of places nearby, I'm gonna print into a different color. So if the street has between 1 and 5 places, I'm gonna paint it green. 6 and 10, I'm gonna paint it orange. 10 and 50, I'm gonna paint it pink, just custom. And if it's more than 55, if it's more than 50, I'm gonna paint it red. These numbers were actually really custom generated. So for the previous map in Sarajevo, for example, these counts were different just because the places had fewer restaurants or fewer places accessible nearby. So this is really after take a look at the table and just decide on the threshold that you want. And besides the color, I also want to change that if there is any places that I can access from that street, I consider with a certain, I will plot it with a certain width. I will plot with the street with a certain width. If that street doesn't have any counts on it, I will color it white, and I will plot it a little bit thinner, just to have a little bit of impact of what are the relevant places. And that's it. So we have all the data that we need. And the only thing that we need to do now is we need to figure out how to plot. And fortunately for us, again, this is all about Python frameworks. So if you take about the OSMNX package, we process everything, we extracted the data from it, we processed the data from it, and in the same way, we can plot the data from it. So it's literally just plot graph. We're gonna send the graph that we extracted, and because we run a for loop to count, to make the colors, to make everything, the lists that we generated with the colors are in the same order of the streets that are inside this object here. So as a parameter, I can just send a list of the edge colors that I calculated previously with the for loop, and also the line width. And only with this, I will already have our Berlin map here. So this is a notebook. if you take the image that is generated because the notebook saved the image locally, you can do the zoom. And with the zoom on this image, because it's pretty big, you will see the difference between all the small streets and their difference in width as well. So all the colors that you saw before on the map, considering Friedrichshain, consider a little bit of, I think it's Preslava back here in the north, you can see the difference in color. This place on the super east is also interesting for me. I actually don't know where is that. It'll be interesting to maybe take a visit. And it's actually interesting considering the difference with Sarajevo as well, on how Berlin is really spread out in terms of places, in terms of shops. It's really like every little neighborhood, a little bit more on the center, of course, but every little neighborhood has all the kind of stores that you would expect them to have. It's not like only the city center have most of the places. It's really quite nicely spread out for Berlin. So this is good for everyone who wants to have easy access for kind of different supplies. I would guess that this kind of same heat map would be different for, or wouldn't be so different for other kind of supplies, let's say supermarkets, gas stations, or even S-Bahn, U-Bahn stations, and so on. Lastly, we have the personalized parts. And when I say personalized, it's really boring, I mean. So we want to plot the map, but we also want to plot some legends, some subtitles, saying what each color represents. And we also want to plot that footer at the end of the image saying that this is Berlin, just to make a little bit more artistic. And this is the boring part. I haven't managed a way to find out, I haven't figured out yet on how to do this automatically, but in order to correctly centralize the plots with the subtitles, and then afterwards with the footer, it's really a try and an error of how much margin I want to give for each one of the laterals above and below the plots that I want to do. So this is really me trying, these numbers are really me trying to get the correct margins for my picture. I create my map, I save it. So you have this from the moment that you execute that cell, you have that available in your machine. And the last thing that we want to do is really to add a border to your picture, just have like a kind of photograph feeling. And this is basically this function that I got from the internet. I actually have to put the credentials for it, but I got from the internet. And what it does is really take the image, expand the size of it, and attach a footer below. So I take that image, I apply this add border function, add the text that I want, play around with the text position. This is another boring part. And I also attach the legend, but the legend is a little bit easier. So as soon as you have this, you have, oh, let me zoom out a little bit. So you have the image that you want. And considering the accessibility for OpenStreetMaps, it's really about changing the query to OSMNX to extract different street networks from different places, and then extract the point of interest for the place that you are interested on, and basically run the same kind of codes. So you can give to a different friend from a different place and say that it was really customized thinking on this person. So you can like give some credits on this friends and say that, oh, I did that just for you. So this is the codes. Again, I'll send a link, feel free to play with it and ask me any questions. There are lots of technicalities that I didn't go into in terms of performance, in terms of accessing and playing with the latitudes and longitudes. But if you have any interest, just feel free to contact me. And okay, I showed you one thing that you could do. Wait. I showed you one thing that you could do with your maps. But what else could we do? So, okay, I took the heat map and I took the street and applied some heat maps. So these are some ideas that I also put on it. So before playing with the alcohol places for Sarajevo, I was playing around with the street lengths. It's really about taking a look at the length of the streets, which comes with OSMNX. And this is one a little bit more treated. So this is really looking at the name of the roads in Berlin and colorizing them basically on the name that they have attached. So if it is a street, if it is a way, a path, if it's an avenue, and so on, which actually makes pretty cool plots as well. And finally, there was a hashtag in Twitter called 30-day map challenge, which is actually where I took this map from. And basically people had to produce different plots for different contents for 30 days in a row. And there are some awesome productions there, and you can get a lot of inspiration, even if it's just to copy, but you can learn some skill with that, or getting some inspiration of what's the next thing that you can do. And it's actually like super nice for paintings, for just putting on the wall, or just given as a gift. And I thought it was worth to share with everyone and try to actually make people to know a little bit more on the OpenStreetMaps. That will be it. This is the link that I'm going to put on the chat on Twitch. And this is my dog, so you're going to know that's the correct profile. He sleeps backwards, so it's easy. And just by looking at this image, this is the end of my talk. And I just want to wish everyone, for who is in Berlin, actually, I don't know the rest of the words, just have a nice holiday. And I'll be open for any possible questions now.